This video is going to go over the global climate we see across the entire planet. So this represents the Earth. We have the equator in the center, poles on both ends. If we look at the relative temperature ranges across the planet, we'll see the hottest temperatures at the equator and the coldest temperatures at both poles. In between, at the 30 degrees north and 30 degrees south latitudes, we'll see warm temperatures. And then at 30 degrees north and south, we'll see cool temperatures. Okay, so we should know at this point that the sun's radiation is making its way to the planet. The areas that receive the most direct sunlight are going to be the areas that are going to be the warmest. And that is generally going to be right here exactly at the equator. So we're going to have warm air. And this warm air is also causing a lot of evaporation to occur, so it's going to be moist air as well. So we have warm, moist air. And warm air has a tendency to rise. So that warm, moist air is rising. As it reaches the top of the troposphere, it's going to start spreading outwards. So it's going to move north. It's also going to move south. So as it's moving in the atmosphere, it starts cooling. It's no longer at the surface, so it's not going to be taking in a lot of water. It's also not going to take in a lot of that heat from the Earth's surface. So as a result, here we see cool, dry air. And as we know, cool air sinks, so cool, dry air is sinking here. And that's at both 30 degrees north and 30 degrees south. Cool, dry air sinking. So just like we saw before, once it reaches a barrier, in this case it's going to be the surface of the Earth, it starts to spread out, so it'll be pushed towards the equator as well as to both 60 degrees south and 60 degrees north. Just like so. At this point, it's been down at the surface long enough to take in heat as well as the moisture from the surface of the Earth. So it's going to warm up. So now we have warm air. But it's also going to be warm, moist air. And just like we said before, this warm, moist air will be rising. So it gets to the top of the atmosphere, it starts spreading towards 30 degrees north and 90 degrees north in the northern hemisphere, and in the southern, it starts spreading towards 30 degrees south and 90 degrees south as well. So again, that's warm, moist air that is rising. Splits. Just like so. Once it reaches the poles, it's been in the atmosphere long enough that it starts to cool down. It's not getting that heat from the Earth's surface. It's also not getting that moisture from the Earth's surface. So at the poles, we have cool, dry air that is sinking. Again, just like we saw before, as it sinks, it's going to hit a barrier, in this case the Earth's surface, and that's going to push that air. So it's going to go towards 60 degrees south in the southern hemisphere, and then that cool, dry air, once it sinks in the northern hemisphere, will be pushed towards 60 degrees south. Okay, so that's pretty straightforward. These are called Hadley cells. It's all talking about convection in the Earth's atmosphere. So we talked about air pressure in the last video I did, so 6.1, 6.2. And here we learned that areas that have warm air, like we see at the equator, are going to be low pressure. And that's just because that warm air is it's not as dense as our colder air. So as a result, we'll have low pressure. So anywhere on here where we see warm air, we expect to see low pressure, just like so. Now, in areas where we have cold air, we have high pressure because we have a high density. So high pressure here, we'll also see it at 30 degrees south, and then both poles as well. We know that in natural systems, everything likes to strive for equilibrium. So in this case, all of these pressure systems are going to play into our wind systems as well. So our wind is going to go from high pressure areas to low pressure areas. So the wind belts at the equator to 30 degrees north look like so. The reason they are curving instead of going straight is due to the Coriolis effect. So the Coriolis effect causes high pressure systems in the northern hemisphere to move clockwise. In the southern hemisphere, we see the opposite. So our high pressure systems will be going counterclockwise, like so. So as we would expect, our wind systems that are in the area between the equator and 30 degrees south are going to move like so. Okay. Next, we have our biomes. So where do we expect to see certain biomes based off of the characteristics we see here? Well, we know we have a regular temperature range going from hot to cold across the planet. But the thing to consider here is going to be where we see moisture. That's going to alternate as we go through each of these latitudes. So our first type of biome is going to be a tropical rainforest. We're going to see those at the equator. So tropical rainforest. That's because that's where we see warm temperatures, and it's also where we see a lot of moisture. So those two together are what makes our tropical rainforest. We also have other types of rainforest. So an example would be like a temperate rainforest. We would expect to see those at 60 degrees north and south because it's a cooler temperature, which makes it temperate, but it's also still going to have that moisture to make a rainforest. So temperate rainforest, and that's at both locations. So that covers our very wet biomes, but we also have dry biomes. So our deserts are going to be found in areas where it's warm and it's also very dry. So that's going to be at 30. So our deserts are going to be at 30 degrees north and 30 degrees south. We also have areas that are cold and dry. These are going to be tundras. We'll expect to see them in the coldest areas, so near the poles, but also in areas where it's really dry, which is directly at the poles. So here we see tundras. Now these are the extremes when we're looking at moisture levels. We also have biomes that are going to be in between these. So not as much rain as you would see in a rainforest, but also more rain than you would see in a desert or a tundra. So these are going to be things like the temperate deciduous forest, like what we live in. So deciduous forests are going to be found in an area where you're going to see different seasons. You're only going to see seasons in areas between 30 degrees and 60 degrees, both north and south. So that's our deciduous forest. The equivalent for the equator to 30 degrees north and south are going to be our grasslands. So again, they're receiving more rainfall than we see in the desert, but not as much as we see in tropical rainforest. So this is essentially just showing how the global climate, so looking at all of these different things that play into climate, affect the biomes as well as the living things that we see on the planet.